So we're kind of continuing this thread of talking about different environments where you deploy IoT. And next we're going to talk about marine applications. Because you're not always able to deploy in environments where you have kind of a nice dry environment. You might be in an agricultural setting where you're going to be exposed to watering, irrigation. You might be required to deploy next to rivers or lakes. You might be deploying next to animals, different sources of water. You might be even deploying in oceans. And so what we're going to do is we're going to talk about marine applications a little bit. We're also going to talk about how to deploy undersea cabling, because this is a kind of a nice example of kind of an extreme environment. And a lot of the lessons we learn from undersea cabling apply to other environments, like how to shield cable and so on. So what I'm doing here is I'm showing you a map of undersea cable that's deployed. You can also go online to underseacable.com and you can see kind of latest maps of all the cables that run underneath the ocean. So when you make a phone call to somebody abroad who's in another continent, or you send IP packets to somebody across the ocean, your signal actually goes underneath the ocean. It goes over undersea cable. And a lot of people think your communication goes over satellites. And that was true maybe 30 years ago. But we've gotten so good at deploying cable under the sea, this is much less expensive than going through satellites. So basically all internet communication that goes over the ocean goes under it, goes through these cables. And so these cables are deployed, but it's a big challenge deploying these cables. Because when you work with water, there's a lot of challenges. And so how are these cables deployed? Well, the first challenge is kind of taking these cables and deploying them out in water. So to do that, we have ships. We have ships that have a whole bunch of cable on them, and they go across the ocean and they slowly spool it out. So on the left side is an example of one of these ships. In the middle, we see an example of one of these spools. So this is kind of like a smaller spool. This is used to cross a lake or a river. On the right side, we see a bigger spool. So this is a huge spool. This thing is full of fiber optic cable. And the ship literally goes across the ocean and just kind of slowly spools it out the back. Now the thing is, when this cable is spooled out, it kind of drops down on the ocean floor. And what do we do with it? Is it safe down there? Well, a lot of times it actually is. In the middle of the ocean, you kind of drop the cable down and you just let it sit there. But the problem is, when you kind of get closer to shore, there's a lot of issues that happen there. There's fishing boats that come out, and if you know about fishing, what they do is they have these big nets where they catch fish, and they do something called trawling, where they kind of run those nets under the ocean and kind of scrape the floor of the ocean to get the fish, because the fish like to be down there. But the problem is, if you have fiber optic cable down there, it's going to rip up that cable. There's also ships that drop anchors down there. There's other sorts of effects. So in certain places, it's better to bury the cable. So when you kind of get closer to shore, where a lot of these activities happen, what you're going to do is you're going to bury your cable. And they don't hire people with shovels to go out and dig under the ocean. That would be really expensive. Instead, they have these tractor-like things where they can have these things under the ocean. The ship will kind of launch this thing out, and the cable will be in it. And what it does is that hook on the back kind of digs a trench, and it'll run the cable into that trench and it'll kind of cover it up. And so these are used to put the cable under the ocean. So to kind of see an animation of this, this is how a cable is deployed. You have your ship where you're kind of spooling out that cable. You attach it to your co-location facility on shore, and you have a private beach. You know, you're going to pay for this beach, so you're not going to have people going in and interfering with that cable. You're going to bury the cable there. You're going to drop it down until you get to a certain depth offshore. And what you're going to do is you're going to drop that tractor down, and it's going to go under the ocean, and it's going to connect onto that cable. And then it's going to start digging a trench. So it's going to push the cable down, it's going to dig a trench, it's going to run out until it gets out to a certain distance offshore where you're not doing fishing anymore. Because people don't fish in the middle of the ocean. The fish like to live near shore because that's where their food is. And so at some point you don't need to bury it anymore, and then you're just going to spool it out. So that's what we're doing here. And so what you're going to do is you're going to take the cable, run from the other side, you're going to splice it together. There's engineers on these ships that can kind of do that, and so on. So when you deploy cabling in a marine environment, you got to think about threats. And you should do this whenever you deploy a system in a new environment. You should, when you build it, you want to make it secure to attack. You want to make it robust to threats. And to do that, you need to build a taxonomy of the different kinds of threats that can happen. You should do this whenever you deploy something. Build a document, kind of go through that document, and then deploy and come back and revisit it. So when you have submarine cabling, there's different things that can affect it. You can get fish that bite it. That actually happens. And this actually used to be a big problem for cable. And then people kind of figured it out, and they kind of made cable even more thick and resilient. So fish bites aren't as big of a problem anymore. If you do look at a breakdown of the most common threats to cable, I'm showing that here as a pie chart, you can see there's a lot of different kinds of threats to undersea cable. There's things like dropping anchor, earthquakes, things like that. The biggest threat nowadays is fishing activity, these kind of trawling operations that are performed, followed by things like anchors for ships and ships interfering with the cable and so on. So what people have done is they've been deploying these cables for years, and they kind of go through this process of kind of deploying them. Whenever there's a problem, they make a note of it and they record it and they do an investigation, and they use that to feed back into their cabling designs. And this is a case study for submarine cabling, but this is something that's important to do whenever you do a deployment, is to pay attention to your failure cases and do postmortem analyses and then kind of figure out how to re-engineer your systems to make them more robust. So how can we build a resilient cable in the first place? How can we make cable resilient to water? Well, let me show you submarine cabling and how that works. There is the cable that carries the information, and the cable has outside of it multiple different layers. And each of these layers has a purpose. So first of all, we have in the outermost level, we have polyethylene coating, and we have mylar tape. And the goal of these is to provide a waterproof barrier. We want to prevent water from getting inside the cable, corroding various other elements that are lower down inside. And so these are good things to have on the outside to protect against water. But they won't protect against something crushing the cable, something biting on the cable, pieces of metal falling on the cable. For that, we have a layer of armor next. So we have stranded steel wires, big thick pieces of steel that coat the wire and prevent strong physical damage. Use steel here and use wiring as opposed to a single sheath, because you want it to flex a little bit. If something strong hits it, you want those steel wires to kind of move a little bit and absorb it. If you use a single sheath, then it might crack, it might tear, and water might get in and things like that. So we use steel wires for a layer of armor. And then we have more layers beneath that. We have an aluminum water barrier to prevent water from getting through if the outer layers get punctured. We have polycarbonate, and then we have copper or aluminum tube. And beneath that, we have petroleum jelly. So we have a layer of oil surrounding the wires. And then we have the wires themselves. We have the optical fibers. So when you deploy wiring in environments where they might encounter water, you want to make sure your wiring is water resistant. You can look at things like IPX ratings and so on. And this is kind of an extreme example. If you're deploying underneath the ocean, you have a lot of different layers. If you're deploying in an agricultural environment, you'll see a lot of these same things. You might not have the armor there, but you'll have things like polyethylene coating and so on to protect the wires from being exposed to water. So what I've done here is I've given you an overview of some of the challenges that happen when you do marine deployments and some of the countermeasures we can do to protect our devices and our wires from water.